Welcome back to The Explainer. Today, we're dropping straight into the dark, terrifying, and hyper-realistic depths of the cosmos to explore the most violent objects in the known universe. Imagine a space so extreme that the very fabric of matter is completely warped beyond recognition. A place where our fundamental understanding of physics doesn't just bend, it simply shatters. Okay, so picture this. You have a stellar corpse that is so intensely dense, a single teaspoon scooped from its interior would weigh roughly 3 billion tons. That's literally the equivalent of a small mountain just sitting in a spoon. But honestly, its immense gravity isn't even the most terrifying part. If this object were sitting halfway to our moon, its invisible magnetic grip would be strong enough to instantly wipe the data off every single credit card on Earth. 200 trillion. Let that number really sink in for a second. That is how many times this object's magnetic field is stronger than Earth's. We're talking about a magnetar. It's a celestial beast that stores more energy in a single cubic centimeter than humanity has generated in our entire history. It's almost incomprehensible.
Section 1. Birth of a Leviathan. Stellar collapse.
So, how does a monster like this even come into existence? Well, we have to trace this unfolding cosmic mystery backward. When a massive dying star reaches the absolute end of its life, its fading nuclear fusion is suddenly completely overwhelmed by its own colossal gravity. In less than a second, the core collapses. The outer layers explode out into a brilliant supernova, while the core itself is crushed into a hyper-dense, city-sized sphere just 10 kilometers across. Everyday atomic structure completely breaks down here, squashed into a shoulder-to-shoulder sea of neutrons. And looking at the data, this extreme physics brilliantly illustrates their violent behavior. While normal rotation-powered pulsars kind of just gradually lose their energy over time, magnetars, which you can see plotted here as the blue squares, are a totally different beast. They possess these insane multiple magnetic fields. So they don't just spin, they literally writhe with unbelievable magnetic tension, making them highly volatile and completely unpredictable.
Section 2. Where physics breaks down. Quantum extremes.
All right, the sheer absurdity of the scale here is where things get truly weird. Think about Earth's magnetic field, the one that gently guides our compass needles. That's about half a Gauss. A magnetar's field? Up to 1,000 quadrillion Gauss. At this mind-bending level, the magnetic pressure in the star's crust actually exceeds the strength of atomic bonds themselves. The quantum effects happening here are absolutely terrifying. The magnetic field is so domineering that hydrogen atoms are physically squeezed into these thin, microscopic needles. An empty space, it stops being empty. Through a bizarre process called vacuum biorefringence, the highly magnetized vacuum literally acts like a prism. It polarizes light, forcing X-ray photons to violently split and merge. Reality itself gets heavily distorted.
Section 3. Starquakes and giant flares. Cosmic eruptions.
Now, what happens when this immense, dark reservoir of cosmic stress finally reaches its breaking point? We see a terrifying chain reaction unfold. Deep inside the magnetar, the magnetic field twists and shifts, building up enormous tension. The solid stellar crust strains under the pressure. And then, violently, it snaps. This starquake launches powerful alpha waves rippling through the star. It acts as a dynamic bridge that instantly converts stored magnetic energy into blinding bursts of high-energy X-rays and gamma rays. What's genuinely fascinating about this is the math. These massive, hyperactive, fast radio bursts actually mirror the exact same energy distribution laws as earthquakes right here on Earth. Despite being separated by thousands of light years and incomprehensible physics, the fundamental math of a fracturing solid crust remains eerily the same. And the sheer energy output? We're talking about 10 to the 41st power ergs for a single short burst. That is more energy released in a fraction of a heartbeat than our entire sun emits in an entire week. These massive tectonic events basically turn the magnetar into a natural particle accelerator, unleashing flares that can outshine typical supernovas by a factor of 10.
Section 4. The extinction radius. Blast impacts.
So this brings us to the real existential dread of this explainer. What if one of the 30 or so known magnetars in our galaxy erupted near Earth? Well, the closer the source, the more devastating the impact. At a distance of 100 light-years, a giant flare would completely fry our satellites. At 10 light-years, it would strip our ionosphere. But if a magnetar erupted within a single parsec, so less than 3.2 light-years away, we would face severe ozone loss, lethal radiation making it all the way to the surface, and the total destruction of our electrical grid. It would quite literally plunge human civilization into the dark.
Section 5. Why magnetars matter. Future horizons.
Yet, despite the apocalyptic threat they pose, studying these boundaries of nature is actually the key to our technological horizon. By observing how magnetars bend space-time and shatter atomic structures, scientists hope to unlock hypothetical quark matter for incredible new supermaterials. They are extreme natural laboratories that let us test Einstein's theories of relativity where they're pushed to their absolute limits, and they even hold clues to inspiring next-generation MRI machines and revolutionary energy storage back here on Earth. But at the end of the day, we are entirely at the mercy of their mysteries. As Professor Victoria Cosby brilliantly puts it, magnetars are not just stronger, they behave fundamentally differently. The unpredictability is total. With a global network of telescopes standing by, we really just watch and wait, because there are absolutely no warning signs or reliable precursors for the next massive cosmic eruption. So I want to leave you with this provocative thought. They are the ultimate engines of destruction for sure. But do their terrifying extremes actually hold the final secrets to our technological future? As we gaze out into that deep cosmic void, we're left to wonder, will our study of the universe's most violent monsters provide the very physics we need to unlock our interstellar future? Think about that, and keep looking up.